Okay, hi. This is college algebra. First section is P7 on equations. Okay. We just want to review all the different techniques you have for solving these things. And on top of that, we'll want to look at harder examples, maybe some examples you're not used to. Okay. So the first type is the linear equation. And one other thing, it's a video, okay? So at any time you can pause the video and try the example on your own. You can, and then fast forward and see what I got. You can rewind the video. There's a button where you can watch it twice the speed, stuff like that. You can take advantage of that. It's like, okay, you can't ask questions to me because it's all recorded, but you can do all these other great things. So it's not good in a lot of ways because I'm not going to be able to kind of have that instant feedback from you, and then I can tailor kind of my teaching to your set of skills. But on the other hand, if you were sitting in my classroom, you wouldn't be able to pause me, you wouldn't be able to rewind me, et cetera, okay? So try to make the best of this pandemic stuff, and hopefully, we'll be back in the classroom next year, okay? Okay, so I just wanted to get that out of the way, and so let's get back to math, okay? Okay, so solving linear equations. An example, something like this, right? So our goal is to get x equals something. So subtract 2 from both sides. So I'm trying to isolate the x on one side. And then we divide by 3. And we get our solution, okay? So hopefully you've seen stuff like that before. Now let's look at a more complicated example. Okay. So we want to get this example into the form of the previous one. That's a common theme in math, right? So first I'm going to distribute on both sides here. Also distribute here. Then I want to combine like terms. Negative 2 plus 3 is 1. X minus 3x's is negative 2x's. I want to collect all the variable terms on one side. And now it's in the form of the previous question. So we should, if we can do the last one, we should be able to do this one. Okay, so move the 1 over. Divide by 4. And there's our solution. Okay. You're supposed to check these, but honestly, if you didn't do anything, as long as you didn't make any mistakes, you're good. Okay. You can check it. It's not a bad habit to have. Sometimes you get more and more complicated types of problems. You kind of forget, do I have to check this or not? So when in doubt, check it. But like I said, if you didn't make any mistakes, there's no reason to check it. These type of problems, the linear equations, you really don't have to check them, okay? All right, so let's take it up even further, even more complicated type stuff. Just calling these examples. Okay, so this has fractions in it. It's still linear. So long as there's no variables in the denominator, it's still linear. And the way we want you to approach this is to multiply by something that's divisible by 3 and 7. Okay? So the smallest number that's divisible by 3 and 7 will be 21. Okay? So I'm going to multiply both sides by 21. So on the left-hand side, we can simplify a little bit, right? So 3 goes into 21 7 times. Okay, or you could think of 21 over 3 is the same as 7 over 1, something like that. So you're just going to end up with 7 times x plus 1. On the right-hand side, we'll have 21 times 5, so 105, minus, and then when I distribute to the second guy, you'll have 21 over 7 right there. And then 21 over 7 is the same as what? Well, 3. So it would be minus 3 times that numerator. Okay. Then we distribute. And it's a lot like now the previous problem. Okay. I need to combine some like terms. So 105 minus 6 is 99. And now I'm going to collect all the variables on one side. And I'll collect all the constants on the other. And then isolate the variable. What is 92nd halves? It's like 46/5. Okay. I like to leave my numbers as fractions. As soon as you start doing like an approximation or like a decimal, you may have to do an approximation. Okay, approximations in math are bad because they can snowball and lead to a lot of error. And if you're dealing with something that needs to be exact, like you're a CNC guy or something like that, you can't have that error, right? So that's why I avoid the decimals. And I really never will use a mixed fraction. So some people like to do like, I don't know, 8 and 6/5 or 8 and whatever. I don't know. I don't do that. I do the improper fractions. So the only people that really do mixed fractions are maybe like people doing cooking and things like that, where you have to do a lot of measurements. I don't know if they do it in chemistry. I honestly don't know, but I just avoid them here. As a math person, I don't really use them. Okay, I prefer if you didn't either, when possible. I know if you okay, I'll just go on. Okay, so if instead of just numbers in the denominators you had variables, then it's going to be a different kind of problem. It'll be a rational equation. Okay. And with rational equations, you have to check your solutions. So before I was saying, there's maybe not necessarily a reason to, but now you have to. And the way we go about doing that is not by like putting your answer back into the original equation. What we do instead is get restrictions, right? So the first step is to kind of note the restrictions. And then once you get done, you compare your solution to the restrictions and answer accordingly. Okay, so let's look at, these are from the book, but the book has changed, so I'm not going to put the numbers down. I don't have the numbers offhand. But, I'm not just randomly pulling these out of the air. Okay, so here we go. Okay, so we have variables in the denominators. It's rational. First thing I need to do is note the restrictions. So how does that work? You have to take the thing in the bottom of the fraction and set it equal to 0. So for example, that thing I just circled in green, I'm going to take that and set it equal to 0. Okay. So that tells me I can't have a solution of -1. And then I go on and I do the other ones, right? So I need to see what happens there. So x can't be 1. And then the third guy over there, let's put him in blue. That's a quadratic, and we'll talk about those here in a minute, but you can factor them. It's a difference of squares. And then set each part equal to 0. We're not really getting any new information, right? because those are just the two restrictions we already have, so that's a bit silly, but there it is, right? Okay, so we have our restriction box. We'll have to use that at the end of the problem. I'll just call it R. Right, so now it's a lot like the previous problem when we had to find something that's divisible by the denominators and the smallest thing possible. Okay, so it looks like the thing we need to multiply by, we need something to get rid of the x plus 1, so we'll multiply by an x plus 1, and then we need something to also get rid of the x minus 1, so I'll multiply by x minus 1 as well. Okay. I'm going to factor the x squared minus 1 just as a reminder that x squared minus 1 is the same as x minus 1 times x plus 1. Okay. Okay. Then on the left-hand side, we're distributing. When I go this times this, the x plus 1s will cancel, and I'll just be left with the 2 and the x minus 1. Okay. If you need that written out, I'll do that to the side here. So if we have x plus 1 times x minus 1 times 2 all over x plus 1, the x plus 1s will cancel, and we're just left with 2 times x minus 1. Okay, so let me write that. Okay. And then minus. And the second one, the x minus 1s are going to cancel. Okay, so again, if you need it written out, oops. So see, well, x minus 1s divide out, and you're just left with the x plus 1 times 1, which is just x plus 1. Whoops, put that back in place. You need that parentheses there because it's minus the entire thing. It's not just minus the x. So you're going to need to distribute that negative. On the right-hand side, the x plus 1, x minus 1s will cancel, and you'll just be left with the 2x. Okay. Okay. I need to distribute 2x minus 2. Distribute this negative minus x minus 1. And now it's basically a linear equation, right? So. Okay, so x is negative 3. Then we need to check that with the restrictions. The restrictions were 1 and negative 1, so we're good. That will be our solution. I think in the software they want you to put it in a set notation, so it'll look like this. Okay. But I think they type in the little set notation part, so all you'll have to do is type in the 3. Okay. Or the negative 3, sorry. Okay, let's look at another one. So again, we start with the restrictions. Okay, and we're getting the same restrictions on that part. Okay. Going to go ahead and multiply. I need to get rid of the x minus 3 and the x plus 1, so I'm going to need to multiply by that. And that x squared minus 2x plus minus 3 is just the x minus 3 times x plus 1, so that will get rid of that denominator on the right-hand side. And let me factor that just to make it, just to what is it? X minus 3 x plus 1. And then I'll multiply by minus 3, x plus 1. Okay. On the left-hand side, the x minus 3, x plus 1 times 1 over x minus 3. X minus 3's will cancel, leaving you with x plus 1 times 1, or just x plus 1, minus the second term. Okay, so that was the first one. And then the second one, the x plus 1's will cancel, leaving you with the negative 2, and then the x minus 3. On the right-hand side, the denominator will completely cancel away, leaving you with 8. Okay, so let's go at it. Okay. You can't leave it as negative x equals 1. You need to multiply that on both sides by negative 1 to get a positive x. And then that's our potential solution. I say potential because we still have to go back and check it with the restrictions. So I look at the restrictions and no, that's not going to work. Negative 1 is a restricted value. Okay. It was our only potential solution. So we don't have any solutions. And that's what we're right. No solutions. Sometimes in the set notation, you'll write this, which just means the empty set. So it's basically brackets without anything inside of it. Okay, so those are hard, but you need to master those. And there's a lot of homework there. I don't want to scare anybody out, but there's a lot of homework. You're going to spend a lot of time doing this stuff. Okay. The next section is literal equations, and these pop up all the time in your science classes, like bio and, well, maybe not necessarily biology so much, but what classes? Physics, chemistry, those kind of classes. So what is it about? It's about solving for a particular variable. So look at an example here. This is a harder example, but it'll work. I think this one has something to do with focus length, which has to do with optics. So if you ever if you have your glasses on if you wear glasses and you have them on your face, and you kind of move the glasses away from your eye, it screws up how you can see things. You can't see as well. So there's like an optimal place to put your glasses, and that's kind of what I think this formula has something to do with that, but I'm not sure. But anyways, it's used. Okay, it's a physics formula. We want to solve it for one of the other variables, okay, for whatever reason, and that's what we're worried about doing. So the first step is to get rid of this fraction, okay, and to do that I'm going to multiply both sides by f1 plus f2, okay. So f1 plus f2, because ultimately you need to isolate this f1, okay, and you're not going to be able to do that with it in the denominator. Okay, so if you multiply by that factor, it'll clear out that fraction. And we're in a little better shape. I need to collect all the F1 stuff on one side. Okay, and there's not much I could do beyond just distributing this thing and kind of looking at where it lands me. Okay, so now I have two F1 terms floating about. I want to get those both on the same side, so I'm gonna subtract F1 F on both sides. So I'm ending up with F2 F equals F1 F2 minus F1 F. Okay, so what do I do now? Now I'm going to factor the F1 out. It's a common factor between these two terms. Okay, so I can do that. So it's a reverse distribution, if you will. Okay. And then I'm there. all I have to do is divide both sides by f2 minus f. And flip-flop the sides, so I'll put f1 over here. And I have f2f all over f2 minus f. Okay? And that would be my answer. Okay, so very important in the science disciplines. We got to make sure you can handle that stuff. So there it is. Okay. Okay. Let's move on to absolute value equations. Okay. And the basic rule is if you have any algebraic expression like u, absolute value of it equal to some c, you can drop the absolute values, but then you have to replace it with a plus or minus on the right side. And how do I interpret that literally? I mean, it's two equations, okay? It's u equals positive c, or u equals negative c. Okay? So that plus or minus thing is just kind of a shorthand way of writing this other statement of two equations. Okay? Math's been around for a long time, so there's a lot of little things that if you're an insider, you know, but as an outsider, don't be afraid to ask questions. Okay? Come see me at my office hours if you need that. Google stuff online, sure. All right, let's look at an example. So I have 2 times the absolute value of 3x minus 2 equals 14. Okay, so the first thing we need to do is to isolate the absolute value. Just like we isolate the variable, here we are isolating the absolute value. So the first thing, isolate absolute value. And you have to do this in that order. There's no way around it. You can't like drop the absolute value and all of a sudden have plus or minus on the other side. No, it's like stuff in math is highly order dependent. It's like when you get up in the morning and you're putting on your clothes, you have to put on your socks first and then your shoes. Okay, you cannot put on your shoes and then put your socks over your shoes. I think you try it, it doesn't work, right? You'll look idiotic. So you have to do it in my order, and it's not my order. I mean, it's the way it's just done, or you'll probably get a wrong answer eventually. Okay, so isolate first. Okay, don't mess around. So we have 3x minus 2 equals 7. Then I have it isolated, so I can drop the absolute values, and I'll have plus or minus 7 over here. And literally, then that means 3x minus 2 equals positive 7, or 3x minus 2 equals negative 7. Okay. And then solve. I have 2 linear equations. Hopefully we know how to solve those now. Okay. So we have 2 solutions. You could leave your answer like I have it written there. You could put it in set notation, like 3 comma negative 5/3, like that. Don't write them as with parentheses. So I've seen some students try to write it like this, and that's not true. Okay, the parentheses mean something different. The parentheses indicate an ordered pair. Okay. And it's actually well defined stuff. So it's like a reserved symbol. You can't use a comma instead of a period. Think about English and the way they write. Okay. All right, let's move on to quadratic sun, and this is probably what you spent the most time on. And we have probably like 4 methods for solving these. The easiest method, and the method you should always try first, is just factoring. So how did that work? We want to set it equal to 0. So I'm adding 11x to both sides and adding 10 to both sides. And then I try to factor it. Okay. And I like to set up my parentheses. It has to be x plus something times something that's 10, but adds to 11. Okay, so 10 and 1. Okay. And then you take the parts and set them equal to 0. And there's our solutions. So always try factoring first. That's the go-to. When factoring fails, you usually want to go to the quadratic formula. So given your quadratic in this form, ax squared plus bx plus c equals 0, the solutions are given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And one thing to note is this discriminant. The discriminant is a thing inside of the square root. I need to erase that, sorry. The discriminant. I think that's how you spell it. It's this b squared minus 4ac thing. And if you find that to be greater than 0, you'll have two real solutions. If it's equal to 0, you'll have one real solution. And if it's less than 0, you'll have 0 real solutions. You'll have two imaginary, but we're not working with imaginary in this section. Okay, so let's take a look at an example. So I have 5x squared plus x equals 2. I need to get it in the appropriate form, so I move the 2 over. Okay. And then my a is 5, the b is whatever's in front of x, which is 1. The c is negative 2. Okay, so my solutions are x equals negative b, so negative 1, plus or minus the square root of 1 squared is 1, minus 4 times a times c, okay, all over 2 times a. Okay. Simplify the discriminant. Okay, so it'll be 1 plus 4 times 2 is 8 times 5 is 40, all over 10. You get negative 1 plus or minus square root of 41 all over 10. And square root of 41, you like to pull out perfect squares there, but there's nothing to pull out, so that's going to be our two solutions. Literally, if they wanted you to write it up, it would be negative 1 plus root 41. So that plus or minus thing is just shorthand notation for two different things. Okay? And then negative 1 minus 41 over 10, if they wanted. But on a test, on a written test for me, you would just leave it like I had it. This would be the answer. So those are the two methods you want to use typically. There's two other methods though. First is a square root property. So for example, if you had something like 3x squared minus 1 equals 47. Okay. Rather than, you wouldn't be able to really factor it. If you brought the 47 over, 3x squared minus 48, then factor out 3 maybe, something like that. Well, I guess you could factor it. Let's say you just didn't feel like it, I guess, for whatever reason. You could add 1, you can isolate the x squared, is what I'm trying to say. And then divide both sides by 3. And then if x squared equals 16, then x equals plus or minus root 16. The problem with this is people always forget the plus or minus thing there. In story problems, usually you always want to go with the plus. So a lot of the story problems, you won't even worry about the plus or minus, and then people forget about the plus or minus. But it's there. It's always there. And when you're just doing one of these problems without the context of a story problem, you need to indicate the plus or minus. Okay? Square root of 16 is 4. So there's two answers to this, plus or minus 4. Okay. You can let's do one more. So like I don't know, x squared minus 1 is 0 from above when we were doing our restrictions. Let me find that right here. Okay, so at the top right, that thing. You could factor it, but you can also use the square root property. Okay, so you can move the 1 to the other side. And then if x squared equals 1, then x equals plus or minus square root of 1. In other words, x is plus or minus 1. So it's a way to get around factoring. Another thing is it kind of leads into the next technique that you may use, but it's kind of harder to remember. It's called completing the square. Okay, so let's look at some examples of doing this. What do we have? X squared minus 6x minus 11 is 0. Okay. So in this case, to complete the square, you want to add in, and we think of a, b, c, and those variables from the quadratic formula. So the b value is negative 6 here. What we want to add in on both sides, and usually you want to get it into this form, x squared minus 6x equals 11, and then we're going to add something. So I move the 11 to the other side, and then I have to add something. So the something is the kind of the hard thing to remember, and that something is b all over 2 squared. Okay. All right. So the b in this case is a negative 6. So we have negative 6. I'm sorry, my six's and b's look exactly the same. I am sorry. I try to put a bigger hook on the 6. Negative 6 over 2 is negative 3. Then we got to square that. That's 9. So I'm adding 9 in on both sides. And that completes the square. And then we have to factor it. So x squared minus 6x plus 9. The way it works is that you'll end up with x minus 3 times x minus 3, which is x minus 3 squared. The other side I have 20 then. And then you use the square root property. Okay, so if x minus 3 squared equals 20, then x minus 3 equals plus or minus square root 20. Okay. And then finally move the 3 to the other side. Factor out any perfect squares. So square root of 20 is the same as 4 times 5. So you can factor out 2. Okay, so we got those two answers. 3 plus 2 root 5 and 3 minus 2 root 5. Okay. Let's look at one more. Let's go back and look at number 80, right? From above. Sorry, not number 80, but you don't have the numbers. Sorry, the one above. This 5x squared plus x minus 2, and see if we could pull this off by completing the square. Okay. This one's a little different because you have that 5 in front of the x squared, and that's going to kind of screw things up. Okay? So what you have to do, and let's first get the 2 on the other side. What you're going to need to do first before you can do anything is factor out the 5. How do I factor 5 out of that x, right? It's x over 5. And then we'll add in our thing that completes the square inside of there. Okay. And on the other side, when I add it back in, I have to also multiply it by 5. Okay? Because whatever I've added in on the left-hand side, it's being multiplied by 5. Okay, so if I add it in on the right hand side, I'm going to have to also multiply it by 5. Okay, it's a bit weird to wrap your brain around, but that's just the way the cookie crumbles. Okay, I'll get rid of all that business. So anyways, again, we need this magic number b all over 2 squared. And in this case, our b is 1/5. Okay, so you can write it as 1/5 divided by 2 is the same as multiplying by 1/2 squared. And then, so that will be 1 over 10 squared, which is 1 over 100. So I add that in. And also on the other side, but I have to remind myself to multiply it by 5. Okay. Okay, so then I can factor, after I complete the square, say x plus the square root of 1 over 100 is 1/10 squared. And on the other side, I'll have 2 plus 5 over 100, which is 1 all over 20. Okay. And then I want to isolate the x plus 1/10. So I'll multiply both sides by 1/5. Well, first let's simplify the right-hand side, right? We can combine those. Need a common denominator of 20. So I'll multiply top and bottom by 20. And that'll be 40 20ths plus 1 20th, which is 41 20ths. Okay. Then I multiply both sides by 1/5. So I'll have x plus 1/10 squared equals 41 over 100. And then take the square root property on both sides. Plus or minus square root of 41 over 100. And then finally move the 1/10 over. 41, square root of 41 over 100 is the same as square root of 41 over the square root of 100. The square root of 100 is 10. Okay. And if you combine those into one fraction, it'll be -1 plus or minus square root of 41 all over 10. And let's scroll back up, right? And that's the answer we got last time. So it gives you another way of doing things, but ultimately, if you keep taking math, it'll be important to complete the square in certain circumstances so you can identify patterns within expressions. Okay, so it comes up in other contexts. So although you can kind of avoid it right now and just use factoring or the quadratic formula, later on you are called upon to do it for other purposes, okay, that completing the square. All right, let's see. Let's just look at one more example in here, and then we'll go on to radicals. This is kind of a long section. We have 3x squared equals 2x minus 1. And then I'm going to move the 2x over and move the 1 over. I'm not going to be able to factor that. So you think about going to the quadratic, but sometimes the quadratic, let's look at the discriminant is what I'm getting at. Okay, so b is -2, -2 squared is 4. A is 3, b is 1. So this will be 4 minus 12, which is -8, which is less than 0. Okay, so if you look back at my discriminant properties, when the discriminant is less than 0, this third case, there are no real solutions. So you don't have to go through all the rigmarole sometimes. You could just kind of, if you get good enough, you can kind of just look at the discriminant. You kind of have to remember the formula for it. But if you do that, you don't have to go through all the business. So no solutions, and you're kind of done. Okay. The last kind of problem we'll look at are radicals. Okay. So 6 And I want to kind of, okay, let's just look at the radicals. The sad thing about radicals is that you have to check your solutions. Okay, the way we solve them, just like with the absolute values, you're going to want to first isolate the radical when possible. And once you isolate the radical, you're going to square both sides to get rid of the radical, hopefully. Sometimes you have to square both sides, simplify it, and then square both sides again. Simplify it, square both sides again. We hope we don't see those, right? Thirdly, then you have to check your solutions. So when I started the lecture with linear equations, I didn't even bother checking. So if I do those problems correctly, you don't really need to check them. But for here, you could do the problem correctly and still get the wrong solution. Okay, and it's because you're squaring both sides of the equation. So let's take a look at one. So square root, this is a hard one. 2x minus 19 minus 8 equals x. Okay, it's not so hard, but it's harder. So first you want to isolate the radical. Okay, that's this thing. You want to get it all by itself if possible. So I'm going to move the 8 to the other side. If it's not possible, you just have to grin and bear it. You're going to have to FOIL out these radical expressions. Not fun. Anyways, we got to square both sides. On the left-hand side, the radical will go away. On the right-hand side, you got to FOIL that. Right? So it's going to be x squared plus 8x plus 8x is 16x plus 8 times 8 is 64. Okay. Then I'm going to collect everything on one side. So x squared, subtract the 2x over, you'll get plus 14x. And then add the 19 over, and you get 40. Subtract the 19. No, what, did I screw that up somewhere? It should be plus. I apologize. I copied it wrong. Okay. So if you subtract the 19 over, then it's 45. Okay. 0. Kind of looking at my notes, so I'm cheating a little. Then you can factor this. You know. It's plus plus, and then you need two numbers, multiply the 45, but add the 14. So you're thinking 5 and 9. And then you could set those equal to 0. And then finally check your solutions. Okay. Alright, so going back here, I'm going to plug those into my equation. Let's just try. Sorry, I'm just going to try the -5 first. Okay. Sorry. Okay, so I'll give myself some room here. So square root of 2 times -5 is -10. So I'm plugging everything back into this equation here. Plus 19, and then minus 8 equals -5. -10 plus 19 is 9. Minus 8 is -5. Square root of 9 is 3. And it worked. Okay, so that one is good to go. Then we try -9. So square root 2 times -9 is -18. -18 plus 19 is 1. Square root of 1 is 1. Subtract those, and that one doesn't work, right? So that one gets thrown in the trash, and your only solution is -5. Okay, so evidence that you must check your solutions. Okay, there's a lot of homework on WebAssign. It's going to make you good at math. Okay, there's 35 questions in this first section, and so get the work. You know, get in there. Get it done. All right, as soon as possible. Okay, so we'll cut it short here, and I'll see you next time.